My session is going to be less polished, so it's focused on the other things. But let me share my screen. So yeah, so this session is COG and STAC kind of intro session, beginner session. It's going to be pretty informal. I'll kind of take you through the slides or some slides that we've developed in the past, giving an overview with a bit more depth than I did in the talk earlier. But I think it's mostly going to be more question and answers. If everyone's had their questions answered, we'll probably end early. But kind of I'm happy to stick around and ask any questions that you've been wondering about all the stuff you saw today. To share screen. Looks like that worked. Can you all see my screen?
Yep.
Cool. So yeah, I think we've covered most of this. Language for geospatial catalogs focused on search discovery, simple and extensible. And so I want to sort of be clear what it's not. STAC's not trying to be a full-fledged metadata standard. There's a lot of big metadata standards, your ISO 19115, FGDC, that really try to catalog all the data. STAC's aiming to be that kind of search interface. You put the fields in there that you want to be searched, and you might link to a full-fledged metadata standard. So we really see this kind of STAC as this layer on top to help make things searchable in discovery. We're not trying to be that single source of truth, to be that only way to represent your data. I think we are starting to see some companies in particular represent, I think Phil from Australia talked about this, where they're sort of just using it for the internal representation because it's a nice model. So it can be used that way, but it's not intended to replace every single source of truth. It says work with what you got. We're not intending to cover all kinds of data sets. And it is pretty expansive, but the kind of key thing is that it's an asset catalog, so you always want to link to another sort of data set. And I think the one we commonly get that people want to put in STAC that we tend not to recommend is putting like a shapefile or kind of vector data directly into STAC and referring to this alternate file. And sort of our recommendation there is use something like Features API, directly represent these things on the web because you can. You have to have a Geotiff. You can't just have a web format of that. So vector, I think, is the one that doesn't fit so well. And then, yeah, we're not trying to be a replacement for all those others. And a bit about how we kind of got to STAC, we really started with a group of people looking to collaborate, and just kind of, a lot of it was actually kind of building specs a bit differently. So a lot of people had experience with the Open Geospatial Consortium specifications, but those were kind of built in a particular way. So we kind of set out to be different. The cool thing is OGC is actually embracing a whole lot of these principles with their OGC APIs. But when we started STAC, it was certainly not the normal way to do things. So yeah, it's JSON, RESTful HTTP at the core, and those small pieces loosely coupled. Scott from OGC was actually talking about that today. I think STAC's played a major role in helping shift that and really embracing the open source tools and practices. All of the work on the specs done on GitHub. It lets us collaborate better, even though we're not writing code. It still is super useful to use all those tools and practices. So the specification itself, what's actually in there? So there's three major entities, and all of them are really pretty simple. So there's catalogs, and a catalog contains other catalogs or items. I don't know what these collections. Collections are sorry, this slide was someone else, and then I'm actually being confused by this slide. So yeah, let's start with items. Items is a single scene or set of Dale files at a specific location for a specific date and time. So every single one of your Landsat scenes would be represented as an item. And then catalogs organize items. So a catalog is let me see if there's a kind of really simple construct. It just has some basic metadata describing it, and then it links to items or to other catalogs. And then a collection is a catalog that has additional metadata. And it tends to be used to group a set of items together, that are the same instrument or the same region. And it has additional metadata about the set of items that are underneath it in catalogs. Links are super important in STAC. We try to be super liberal with links to show those relationship. It's how the web works so well. So every link has the ref to the actual thing, and then we make liberal use of these rels. So one of the things a couple of people mentioned was this derived from tag, where you say you link back to the original item that you're coming from. Yeah, so these are a few of them: root, parent, child, and item, derived from previous version to really describe how do all these little pieces fit together. And then a STAC catalog, like I said, is pretty simple. It has an ID, a title, description, version and extensions, and links. And it's really about just linking down to other pieces. And then a collection, like I said, is a catalog, so has the same properties of organization, but then adds in description, keywords, license providers. And then a STAC item is a GeoJSON, and this is a pretty early core decision that any STAC item you could load up in any GeoJSON viewer, and you'd see it, and you can click on it and work on it. So that means most of the interesting stuff is under properties, because that will show up in GeoJSON readers. And then we add in a couple other fields like assets, links to the collection, kind of meta information about the version, the extensions in the STAC item, but any GeoJSON reader will be able to understand the STAC item, and then someone that understands STAC can make greater use of what's in it. So then within the properties of an item, date time is the one that's required. So everything must be a spatial temporal thing. Spatial is provided with GeoJSON and geometry there, and then date time, where it gives us the time. And then there's now an option to do a range of times instead of just a single date time. And then there's a few core common metadata things like platform, instruments, constellation, mission, title and description, and yeah, date, time, created and updated, that are sort of in the core spec, but the key is that it's very extensible. So you can put in your own properties, you can use extensions that define more properties, and kind of put a lot more into it. And then assets are the actual thing. So there can be some confusion between links and assets, because you could have links to all your assets, or you could define some of your links as assets. But assets are really the core files that represent the data. So it's you probably think of it in that traditional geospatial world, like what would you download into a file if you're downloading satellite imagery? It'd be all the bands, it might be some browse products, it's probably some metadata. Those are the types of things you'd have in an asset, but they're all supplied online, so you can connect to them without having to download the entire thing. And then content extensions are where STAC gets super flexible. So like I said, you can have whatever you want in properties. And we really encourage people to put more stuff in this, but a lot of people work in a similar domain and they'd like to reuse the same thing. The example I gave was cloud cover. lots of people representing cloud cover stack, we don't really want them to each make their own cloud cover. So content extensions are this way that people can kind of collaborate and say, hey, this is the one we're going to use. A bunch of people think about it and pull it into the spec. But anyone can propose an extension. They go through kind of maturity. Right now, they're all proposal because we sort of reset it. We went to 1.0 because we felt, or 1.0 beta because we felt enough had changed. And what we're going to do is track all the actual implementations, especially after the sprint, of who used which extension, and then plot its maturity based on real world implementations at 1.0 beta 2 level. So these will get refined to, so you can kind of understand, like, is this some idea that somebody just put out there, or is this something that many catalogs are using? So yeah, there's a bunch of them, general ones like satellite, specific SAR, versioning stuff, view geometries, projection information. And yeah, that projection actually highlights one thing is, I think I said this earlier, but we do recommend STAC for search, but some people do want a bit more from it. So projection information is something you don't really search on, but is really common and useful to have. So you can add that in, and then smart clients can make use of that directly without having to inspect the files. There's another extension I worked on this last sprint called rendering hints, where you can put hints about the data, like zoom levels that a tile server might want, so it doesn't have to work as much to open the file with the COG, can get enough information from STAC to be able to start to do stuff with it. Maybe I'll pause there, because that's probably a lot, and see if there's, I don't even know what my next slides are. Yeah, any questions on STAC in general, or the core constructs or extensions? I will give 20 more seconds of uncomfortable silence to see if anybody pipes up.
All right, I got one. I guess, so starting out pretty basic on this on my side.
Yeah.
Say I have like 10 Geotiffs that I just want to make my, like, for Hello World stack. How many, I guess, levels deep would that kind of thing be as far as catalogs? Or, I mean, it would just be like, I guess, one JSON file that's a catalog, and then that has links to each TIFF in it, or?
Yeah, I'd make it, probably one catalog for total Hello World. Here, I'll show. So this is my Hello World stack catalog that I've used to, help me understand stack and to track the versions updated. And I aspired to put more into it, and all I ever did was this Hurricane Harvey one. I thought that we'd put more. I did a more of a hierarchy because I thought I would put more stuff into it. So it goes down like 2 levels and then has 5 items in it. But yeah, I mean, I think if you're just doing a total proof of concept, if you just want to get 10 up there, I think Mateus in his section took 1 item and put it up and published it. Yeah, he talked about it in his lightning talks. We can all try that together if you want. I'm not prepared to be able to do that, but it's not that difficult, so we could do it together. But yeah, this is definitely my Hello World one, so I can give you like the quick.
Okay, just a catalog in every folder.
Yeah, and generally a catalog sort of corresponds to a folder. It doesn't necessarily have to be organized that way, but it's like, it probably should. It's a pretty sensible way to organize it.
Right.
You have cloud buckets, and they're all roughly folders. So yeah, technically it doesn't need to be, but
Yeah.
and I think people are playing with like command line tools, and I would see those like, yeah, be able to just like navigate a folder structure that you have and be able to generate the catalogs from that. People can do that with PyStack. I'm not a Python developer, so I've been waiting for the command line tools and helping encourage like, hey, these are the types of things I would want to do.
Right.
And I think it's going to be hard to have like a general command line tool that just is like make stack catalog. But yeah, thinking about things where, hey, somebody's already organized a directory of Geotiffs on their computer, and they put it in those folders that they want, just automatically make that catalog from that and extract out the metadata that you can and then edit a bit more.
Okay.
So, but generally, generally a catalog corresponds to a folder. So that in this one, I had the root one as a collection. A pretty common pattern that you'll see, especially on things that have lots of data, is you'll have a catalog at the root that will have several collections. So like if you have Landsat data and Sentinel data and CBERS data, you might have a catalog at the top and then have collections of those beneath it. And then even CBERS, like they have 4 different satellites. So they'll do collection, or 4 different sensors. So they'll do collections for each sensor. So you kind of use, catalog as your folders, and then you'll have more catalogs beneath your collection to kind of, and it's roughly to divide it out, in a way that would be sensible to browse. Mine's pretty simple. I have a collection at the top, so it has information about the provider, it has the keywords, the license, the description, the extent, summaries. I just recently tried to put in to kind of put in there, and then you can see this one. I don't really know why I did this on Brave, because I'll have to enable JavaScript everywhere. So then this is generated from that catalog. And yeah, I showed this pretty quickly, but it's worth showing. So like this literally is the catalog. It's the same stuff as here. And then this entire thing is generated just from these JSON files. But yeah, there are links that you can click on. You can follow through on those links. And then each of the items, if they're cloud optimized Geotiffs, which these are all, become these maps. But yeah, it's pretty cool because all that's behind this whole thing, where I can see where it is, I can get thumbnails, I can download these, is just this file.
Okay.
So it just sits there. It's just this simple JSON. And then the collection you kind of saw. So yeah, this collection, this stuff, I filled out. It does markdown, so you can put links into it. I filled that out to have this.
Okay.
Then like the license links to the license. And that one, I think we'll just recognize if it's an SPDX, then we'll put a link to it. Like we recognize the SPDX ones. So all of this is just from this simple JSON file. And I think we'll eventually have summaries show up in the Stack browser as well. And then the catalogs, the boringest one. Let's sort of do these together. It's just title, description, and then the links down. And it's just, hey, this is the August 31st one. You could imagine a couple of days of captures that I was imagining, but Planet only released the one day. So these are the ones from that day. And then this is an item. So again, GeoJSON, it's got the bounding box. We require the bounding box to help search the geometry, and then the various properties. with a few different extensions. So yeah, like I was talking about cloud cover, and actually with Planet, you know, I had to transform this data. I think our cloud cover is 0 to 1, and Stacks is 0 to 100. So we transfer it into this sort of more known format because the tooling will understand all of this. And then, yeah, let's see, we can pull up this one. So yeah, you can see the properties here, you know, get listed here. And then the assets are here, and they turn into nicer links that you can download. And then these are, like, you can sort of take these directly if they're cloud optimized Geotiffs. And so like the little maps I was showing earlier. Yeah, stupid. So yeah, I can do it with this cog map instead. But I just like take the link directly from the asset. I mean, it's also a Geotiff. I can click on it and download it to my desktop. But yeah, that's also the direct cloud optimized Geotiff link that you can use directly.
Cool, thank you.
Yeah, that's probably a better way to go than me trying to read through these slides. Any other questions in there of anything that I just showed or from anybody else?
Yeah, just to, you know, carry on with this. So this was like, you know, I think you mentioned PyStack. So is that the library to build your own catalogs or? Okay.
Yeah, exactly. So there's a session that I'm working on getting downloaded and uploaded that Rob Emanuele did earlier today on like all about how to use PyStack. I actually had him do a tutorial at the last one, so you can search for PyStack tutorial. But yeah, you need to know Python, and I don't know Python, so I've like tried 3 times because I'm like, I need to make a catalog. I want to update this catalog to be more than 5 stupid items because like that's all I can do by hand. But yeah, PyStack, you know, like, you know, Python, it's like Google, you know, like read all the stacks in, read different formats in, write out catalogs, manipulate your catalogs. Yeah, I think it's pretty extensive.
So basically, if you're starting, actually, I'm creating a metadata, you know, like I have a bunch of DEMs, you know, hundreds and hundreds. So I read all those DEMs, get the bounding box, all those things. But I created save file because my consumers, they want save file. That's what they understand, or some other format or GeoJSON. But this seems more, I guess, future-proof, right? Is that the word?
Yeah, I mean,
so where will I go? Let's say I have a GeoJSON that has all these attributes like, you know, cell size, projects, and everything. Now, how do I call it a stack or something like that?
Yeah, I would. Do you know Python?
Yes.
Yeah, like I would start with PyStack. So like PyStack, like basically, I think PyStack's building up like tools, but like you should be able to read GeoJSON in Python. You'll get some sort of Python object.
Okay.
And then I don't know Python that well, but once you're into the stack Python object, then you can just write it out and you sort of have it. So you might have to write a bit of code to like read from your particular fields to translate into it. But that's kind of like what people do with PyStack. They're like, I need to take this new data set in. I'm going to write a little Python thing that says, how do I read this data set, you know, into Python and translate that into Stack? And then once you have that written, then you just can read any of those into PyStack, and then PyStack you can just organize it in the way you want once you have it in there.
Is there some example, you know, you can point to? I mean, not right now, but at some point, like, hey, this is, you know, an example of how we did it from raw data to, or something along those.
So yeah, there's a couple of them. That's latest. Yeah, so there's there's like a few of these, and like I said, I think these are a little outdated. Rob, like 3 hours ago, recorded a new session, so we'll try to get that one posted, and he has a new Python notebook for that one.
Okay.
So yeah, it'll be posted for all of those pretty soon.
Thank you.
Yeah. Any other questions?
Have you seen any good patterns for how to start cataloging or track catalogs of data that's not necessarily open? So if you know someone has a bunch of Geotiffs, but they're not in an openly shared bucket, have you seen people make STAC catalogs of those, and how do you manage kind of getting access or sharing the data while also cataloging it?
Yeah, it's a good question. So Matthias earlier suggested this, and I hadn't thought about it, but I agree with it. So Matthias has been a core member of STAC for a bit. He's kind of funny because he works on a project that has just never had items in it. He has only collections. And it kind of makes sense. Like Earth Engine also doesn't have items, and I would actually admit that it's a more sensible way to work with things of just like, you just have data. It's like you were saying, Ash, like, why do I have to know that there's all these scenes in it? I don't care about the scenes. And so STAC is sort of made as a tech to help build those engines, because you want, like, at some level you need that, but yeah, then there's some that should just abstract that out. So he just works in collections, and because OpenEO like abstracts Earth Engine and other tools like it. But he was making an encouragement to private data sets that to at least have collections. They might have items internally, but at the very least sort of publish your collection so people can sort of know about it. I'll admit that I'm sort of, one of my big frustrations with geospatial searching of data previously had been the amount of times you search for something and you can't actually get the thing. So I think STAC is sort of like very centered towards you need to get at it. But I do think we're going to need patterns, for that sort of search, but something behind an API. And actually one of them that I want to solve sooner rather than later is ML Hub. They aren't trying to keep the data private, but they sort of want to make sure the license terms are respected, and like they want to be sure that people aren't just blowing out their egress charges because things are requester pays. So we actually don't yet have STAC browser for those because you need that API to authenticate. So I think it's one of the next things we need to tackle is, like, what's that good pattern? I have some ideas, but I don't think there's we don't have like a best practices. I could see some where you might have an alternate. So, sort of the option space, you can make a STAC catalog with a single asset, and that asset can just be a preview thumbnail, so you can do that today of just not really expose something like, some way to indicate that, hey, there's an asset here, but you need to be able to log in to get the full assets or something like that. Another one, that we face at Planet, and a few people have brought this up, we still don't have the clear answer in STAC, which is when you need to generate the asset. Somebody's brought up they have a bunch of data on tape, and it takes a while to turn things in tape, but Planet, Digital Globe, like we don't have a bunch of cloud optimized Geotiffs for all the data pre-produced. We have to hit an order system that then generates it. So there's a bit of work in STAC to have a common pattern. The core of it is that STAC is flexible and allows you to do stuff, so you should be able to find an answer. But we hope that we can kind of have a better pattern of you have data that you want searchable by the public internet, but you can't make it available. You need a login, or you have it on internet. Like, what are those patterns? So I think no great answer yet, except it's flexible enough to handle all the things, but that's a less satisfying answer. But good question, and one that we still need to tackle well. Other questions?
I just posted on the chat. So basically this authentication thing, like sometimes there are some buckets where you have to, it's like a user pays bucket. And the question is, do we have some examples or how to, like, I think some data from, at least for Sentinel-2, they say it's like user pays if you're in USA.
Yep.
So I can use stat search around to request with other catalogs, but as long as it's like user pays, there is like no way to authenticate. Is that still the problem, or do we have some work on that? Or
Yeah, I mean, if it's user pays, like you can, yeah, I mean, you can access that with, you know, one of the clients that will work with it. You know, so you can get into it. Yeah, I do hope we get to like a better solution where, you know, you can browse the catalog. And I think that's the thing, like the intent behind a lot of the user pays ones are not, they don't really care about the metadata, they care about the actual data and the cost of that bandwidth. So yeah, it's still an open question of exactly how to do the user pays ones that much better. I think what we've, well, that said, we definitely have catalogs of stacks that are, I feel like there's a couple. But yeah, I think we don't have a great answer for it yet.
Hey, Chris, do you mind if I make a few comments?
Yeah, or
Yes.
no, I don't want.
This is Woody Wallace from Synchrony.
Hey, yes, you guys have tackled or had this.
Yeah, so so we were trying to work with NAPE, and also we have some clients who are local data providers who basically have mixed permissions for the data that they want to distribute. So for, say, you know, county level data, they might want to make that private, but then for state level data, the state might want to make that open data.
Mm-hmm.
So so what we've done is we've done authentication at the STAC API level. This is all done with, like, you know, the stuff that worked with STAC version 0.6. So we have to probably update this now that there's new and interesting things floating around out there. And then we've also kind of wrapped some of the old PyStack with kind of our own like worker-based indexer. So I posted that. It's called STAC Gen, and it's out there in GitHub. That's
Yeah,
source.
I remember that.
So that will read from S3 URLs, and then that kind of gets you around the requester pays and the authentication issue. So if the AWS user that you're running StackGen as has access to the bucket, either via requester pays or if, let's just say it's a private bucket, then you'll still be able to create the stack files for it. And then where you put the stack files can have issues. So you can run into issues with them needing to be open in order for certain things to get access to it. And so that's where we've kind of put in the, try to deal with authentication at the API level as to whether or not you can get access to the stack information and therefore would have access to the catalog.
Awesome. Yeah, I saw a couple of your things recently, and yeah, I think Woody has dealt with this a lot more than I have. I've been like, public data, get it available.
You can make it. I guess the short message is that you can make it work, and there's a few things to kind of work around.
Yeah, it'd be great to put it in. We have the STAC best practices section that is becoming quite long, but it's like, yeah, as the community learns stuff, there's a lot of things that aren't there's nothing that about this that should go in the spec. You know, the spec's simple and it will work, but put it in a best practice section that says, hey, people have found this pattern, you know, do this, you know, authenticate in the API, keep that behind the firewall, et cetera, I think would be great to see.
Yeah, if there's a place to talk about patterns, then we can contribute to that.
Yeah, that'd be great. I mean, yeah, we should see. I mean, I feel like there's a best practice .markdown in the repo. I'll pull it up. this is a poor choice to use my Brave that this is like to present, but now it doesn't have any of my things completing. Best practices. So yeah, it's like date time selection and unrectified satellite data and when you want to use additional fields. I mean, I feel like I'd want to see like, there's probably a lot like on authentication that's probably more than would fit in the previous ones, but I also could see like sort of crystallizing to like the key recommendations of like this, and then maybe link to other things that, yeah, like kind of explain more.
Sure. Yeah.
Whatnot.
So the short answer for me, like let's say I'm looking at this Sentinel-2 that says requested page S3 bucket. So I don't have an easy way of accessing data using STAC API, right? That's the answer for now. Like right now, if you want to download that data, I mean, I'm willing to pay the data. I just don't know how to pass those authentication using STAC.
I mean, if you're just, so yeah, like
somehow you have to create the stack item.
Yeah, and I guess the thing is, I think Earth Search is probably what you want to use for most of it. Like Earth Search is basically Earth Search is a STAC API stood up by Element 84 that sort of any AWS data set that implements STAC gets crawled for free by Earth Search. And so with Earth Search, I think it will crawl the STAC metadata and provide an API, so you can search for the data. And then when you actually want to pull the data down, then you need to
okay.
Yeah, let me see if I can find it.
I mean, searching is not a problem. Like I can search the data, like they tell this is the data, and now say if you want to use it, even download it to do something with it, then they want you to pay. Like this post I just posted on the chat is from Sentinel. So the idea is, how do is there some example that I don't have to spend another week like digging into just to download the data? That was my question, but thank you.
If it is requester pays, then the link inside the link to the asset will be an S3 link instead of an HTTP link.
Okay, so how do I pay? I mean that was my question. I couldn't find out a way to like, okay, this is my AWS account. Deduct money from this account. I mean, there was no way to pass that information to download or to access.
So when you access an S3 link, you have to access it through an AWS client in which you provide your access keys.
Okay.
Establishes your identity, and then AWS charges you behind the scenes.
Okay.
To access it.
But Chris was saying that there is a new catalog coming on from another one, right? From that they are trying to catalog everything for free. Sentinel. I think they are doing. It's not complete yet, but it might be someday, maybe a few days.
Yeah, I'm trying to. So Digital Africa. I'm trying to remember if Digital Africa is COGS or S3 or not, but I think it is a point. So yeah, like Woody said the answer, which is you just need you just need your AWS command line configured like with your account, and then you just pull the S3 link down directly. I am interested in if there's some way. I mean, to me, this is like a general problem.
Yeah.
Of S3, like whenever I get an S3 link that's requester pays, I'm like, oh, I still haven't configured my command line and set up the credit card. I'm like annoyed by it. So like, I do think there's a space, and maybe it's pushing the providers a bit more to like have some web thing or have something that just lets you put in your credit card easily and pay. Because I think it is. I agree. It's too high a barrier to entry now. And I mean, this is across any S3 requester pays or requester pays type thing on any of the providers.
I mean, the whole thing about using STAC is make everything easy, frictionless, and now you get into this hole where it's like crawling through. I don't know. Anyway, thank guys. I mean, that was good information. Anyway, I don't want to take all your time.
No. I mean, this is the time for that.
Okay.
Totally.
Is that the level behind you?
Oh yes, who is this?
This is Adam. I went to OSU. Oh, my camera's off.
Okay.
Yeah,
Hey.
I got
Yes.
my
Ohio.
Ohio shirt on.
Okay. Yes, Ohio State.
Oh, I thought I recognized that.
Yeah.
Yeah, the place I want to push Radiant Earth, because yeah, they have the Mail Hub, which is totally great, and I totally want a Stack browser for it. And I kind of want to push some of those, yeah, people doing things on top of Stack to like pay some limited requester pays bill. And this might not be possible, but it feels like there's a difference between downloading the data and like streaming it as a cog, you know? So I think like that's the thing to figure out. Is there a way that we can have, you know, some providers that help make the data more available? Because yeah, what everyone's worried about with requester pays is like people just dump downloading the whole thing out of the cloud. You know, what the reason it's there in those is for people to work in their cloud and stay in their cloud, or to just stream bits of it. I think there's some place where we could have at least Stack browsers that, you know, you can see it, you can visualize it, but you can't download without logging in. And yeah, maybe it's actually an opportunity for Radiant Earth to like, yeah, let you log in. And if you're logged into ML Hub, you could charge. I mean, I almost see this as a business opportunity for somebody of just like take a credit card and charge and access to S3 stuff. Like I would certainly pay for that.
I will pay for it.
All right. Well, we'll have to talk to you about Syncardo, because we do that, and you can. We've shown that you can tile stuff from a requester pays bucket with Marble Cutter virtual.
Nice.
Presumably the other one, we haven't tried TI Tiler or T Tiler or however you pronounce that, but it's possible.
Mm-hmm. Yeah.
Awesome. Yeah, let's do a blog post or something on it. I mean, yeah, probably get to upgrade to 1.0, and then yeah. But yeah, I mean, I think I definitely see it as a problem of the requester pays bucket is a totally reasonable thing, and I want to support it. But yeah, that gap between a normal user and configuring my AWS command line client, like for even me that, you know, again, I'm not a Python programmer, but I'm comfortable with the command line. It just, and I'm sure I could set it up, but every time I'm just like, I got better things to do. Like,
yeah.
Let me try to find my presentation again. Any more questions while we're?
Maybe one. I've been kind of thinking about, like, as far as the internal hosting stuff. If I wanted to stand up a browser that was like the, you know, lowest barrier vanilla browser for just having a map where you can, you know, click on the menu for all your different TIFFs. It seems like, I mean, I thinking about it, I'm like, I kind of think like maybe clone the map from Cogio, or I don't know if you know, I also saw the open aerial map that looks like I could just point that over to my own stack, but I'm not sure if I could understand that right.
Yeah. Well, OpenArrow. I need to circle back. I need to figure out who's doing OpenArrow map. So we talked to them super early days, and Seth Fitzsimmons was our kind of like link to them, but we never quite got to OpenArrow map implementing Stack and having their tools like understand Stack. I mean, OpenArrow map in many ways like was a major inspiration on a lot of this stuff. Like there's like a small group of us, I forget what it was even called, where we like, yeah, thought about small JSON files for this stuff. Yeah, no, there was a Stack browser project that DevSeed started, but didn't quite go there, where you could like, yeah, it was just Stack APIs. I don't know. The quick answer, there's no great things for what you want right now. The COGO map I laugh at, because that was literally my first coding project in 10 years and continues to be my only coding project in 10 years. Like, and somebody posted something with it the other day on Twitter, and it had like cholmes.github.io in it. And they're like, oh, like I'm behind it. I was like, no, like somebody just used this code to like pull in interesting data. But it's like, it is not great code because I am no longer a software developer. I mean, I enjoyed it a whole lot, like getting up to speed with open layers and figuring out how to make the stuff work. But it actually, it like that request was like, there should be a better default viewer than like I built that 3 years ago, hoping that would go further, you know, or somebody else. Like it was like to show the proof of concept. So I think there's still space for, yeah, just nicer tooling that, you know, pulls all the cogs. I mean, that's a lot of chicken and egg, you know, and I think we're pretty close to like solving the chicken of having enough good data as COG and STAC that like other people will start to build on it. And I think we're like just on that precipice because like, yeah, like the guy from Esri, he looked into a bunch of, or like, he asked on Twitter, like, are there more mature stable stacks? You know, I've just been finding experimental ones. It's like, yeah, we've kind of just been moving versions. And so people haven't wanted to upgrade their stack every single time. And I think that's the what we want to do in the sprint is just, hey, these are the set ones and get more and more. So I think once we have that, then it's like, oh, I could just write a tool and, oh, I can get hundreds of millions, if not billions of data in it. So,
Okay. Well, maybe if I make any improvement on it, maybe I can push that.
awesome.
Yeah.
You might, if you're talking about doing it in a browser, like reading directly into, say, Leaflet, or something equivalent, Daniel DeFore has been working on GeoRaster or some plugin like that for reading COGS directly into the browser.
Okay.
Yeah, and the EOX COG Explorer. I mean, yeah, there were a number of talks at the Lightning Talks. COG Explorer.
Yeah, I had, yeah, some of those were useful. I guess I was gonna try to design the page a little bit to try to customize it for some of our stuff, but that I have had some success with that though, with the CoGeo one and then the EOX one. I guess I haven't tried that one too much yet.
Cool. Any other questions on Stack? Oh, I just realized I'm like way over time, but that's cool. I got nothing else to do the rest of the day. That's not true. I'm just going to chill out the rest of the day, but happy to answer more questions. Does anybody want, I only put like 3 slides on it, but does anybody want the quick overview of cloud optimized Geotiffs? I'll do it really quick. So this is mostly pulling some other slides, but the sort of key thing about a cloud optimized Geotiff, the typical way that a TIFF is written is every single pixel is stored in a line, whereas a cloud optimized Geotiff says you must store them into these tiles, which makes the access way more efficient. And then it also requires these overviews so that if you are zoomed out on a tile server, it doesn't have to read in every single pixel to just give you an image when this is all that you're looking at. So those 2 things are really the core requirements of cloud optimized Geotiff. And yeah, as Evan said, there's nothing really new about cloud optimized Geotiff. People have actually been organizing their Geotiffs like this for a while. The main thing we did, part was just me doing it, was like call it a thing and put up a website and kind of constrain that scope. So like people who have super deep in Geotiffs are like, why does this even matter? What's a cloud optimized Geotiff? I already do that. But I think the thing that has made it work is that it gets everyone to agree on that. And if you set it up in that way and are valid cloud optimized Geotiff, it's just going to perform much better on the web. And then, yeah, the other key thing it does is, Evan talked about this, the IFD files, which is kind of the table of contents of the TIFF. So that's the other key thing, is it puts that at the very front of the file, because in TIFF and Geotiff, you can stick these things anywhere, all over the place. But if you have a web client, it's not able to kind of seek and read on disk. It can just make that one request. So that's the kind of magic behind cloud optimized Geotiffs is you put that table of contents up front. The web client in those first bytes can get it, know where to access, and then the data is divided up in such a way that, yeah, it can just pull the exact piece that it needs without having to read through anything more. So yeah, that's kind of the core thing behind cloud optimized Geotiffs. Any questions on that or anything else on STAC?
So just for a TIFF, can you, I mean, can you, when you read a TIFF, can you tell whether it's a cloud optimized Geotiff or just a normal TIFF? Is there a way to say that? Find out, I mean, that was my question.
I mean, yeah, so the tool I usually use is this online one.
Okay.
So if you have a file, like, so you can choose a file and upload it, but it only does like 10 megabytes because it's just checking it. Or if you put their file in the cloud, then you just put the URL directly into it. So, you know, like this one, and it just says, I guess it's not even a Geotiff. I don't even know what that was. We can do this one. And that's a Geotiff. And then and then the easier, and then RioCOGeo is probably what, yeah, if you're doing Python, this is definitely the way to go. You can do validate. And I think this gives you a command line tool as well. So that's like an easy Python way, a command too. So yeah, those are, if you're up in a development or terminal environment, those are the super easy ways to check. And then they both make it really easy to just turn whatever you have into a COG as well.
Thank you.
Hey, Chris, I had a question about using floating point data in COGS and in STAC. Most of the examples have been RGB data or imagery or data that's been coerced to that. So if I have like a DSM or a DTM, can I leave it as float and have everything work?
Remember, I think for the most part, yes. Like some of the tiling tools that do visualizations of it, like they won't necessarily know what to do, you know, like, cause it's not an RGB. But in terms of like the core accessing and making it available, like it will be a COG, it will be in STAC. There was one recently that was like bird occurrence data that was like COGS as TIFF stacks, and yeah, it worked less well in the default ones. We are working on, I think I mentioned this a bit earlier. One of the things we do want to do, we only have 2 properties so far. I need to add another one on like min-max pixel values. And yeah, so this should like, yeah, like this, you should be able to say like, hey, this is a float. So this is, and this is one of the ones that's like, this isn't really search, you know, like, you know, to find data. I mean, maybe you want to know the data type, but these are mostly for hints to the renderer to say, hey, this is what this is, do something with it. So like, yeah, I mean, the ones we're contemplating, yeah, there's like a big PR about this that I think I just need to like finish the work off, because it's like kind of complicated. By a big PR, I mean a very big PR. It's mostly like discussion about, but I think where we ended is we're gonna do min-max pixel values as a rendering hint. So you'd be able to say, and then And then there's also a proposal to do like to do stats. So yeah, I think and I'm like slightly out of my depth with this. So if I start saying like total gobbledygook, I probably go much deeper, but like, it's like I like 90% understand it. There, for COGs, I mentioned in the main talk that one of the things you can do with them, this might just be imagery stuff, but I think it probably helps with this float stuff, is if you do GDAL translate -stats, it'll embed TIFF tags that have your min-max statistics. And then Marble Cutter, that Seth Fitzsimmons worked on, like, it just came about when I like put some Planet Analytic data into like Marble Cutter and tiles.radio.io, and it just looked like crap because it was rendering every single little tile differently because the stateless Lambda tiler didn't know what it is. So that's when we want to write up to be, and I've seen a few other people reference it. I think we just need to like get it together, write it up so people know, because a few tools understand it. And it's just like whatever GDAL does for stats, put into the TIFF tags, and then let renderers look up to say, hey, these are the stats on min-max standard deviation. I forget exactly what GDAL sticks in, but it seems to work well in most use cases. And yeah, and roughly like that's the type. I think the appropriate place for many of them is actually in the COG and just overloading the TIFF tags, because you can do TIFF tags. And I think we're open to STAC also having some of that, or having rendering hints that make less sense to put directly in the COG. But yeah, I think this is emerging. So yeah, roughly stick floats in COG, it'll be fine. It may not work with all the tools. And then I think there's people that are interested in getting it to work more with the tools.
Yeah, I've been thinking about it in the context of like playing nicely between like STAC versus like WCS, which I know can have some of that metadata in there. But yeah, thanks for clarifying. Appreciate it.
Yeah, of course. Cool. Any other questions?
Yeah, I've got a question. So let's say you have a tile data source, so like many cogs that make up a catalog that represent a mosaic, but you want to represent that as at a much lower zoom level, so zoomed out farther than what would be efficient to render out of the top level overviews of all of those cogs. Do you, or has there been discussion about doing that?
Yeah, so there's been some work. It's still pretty early. This is another one where I'm like 90% understanding and want to dig in more so I can explain it better. The first thing that kind of came up out of the desire to do that was this mosaic. Well, okay, so at a baseline, there's, okay, let's start.
Well, I know you just started talking about this rendering hints thing, and that seems like it might help because then you can have maybe multiple tile sets in STAC, and then you can have different hints for on the different catalogs.
Yeah, so okay, baseline to start with, this is still a proposal, but there's this tiled assets thing. This was a bit more made to just not have to make a STAC item for every single cog that you have when you're doing a regular grid. Because yeah, you can just have a whole bunch of those. I also think it's okay to have STAC files, but yeah, so there's, I'm interested in there, it's not done yet, but I'm interested in like a general spec that is just like, if you have regularly gridded stuff, to be able to like have renderers understand that better. And then this mosaic JSON stuff actually came from a similar desire, but yeah, I think this explains it decently. It's like a sort of virtual raster for the web. And what they do, let me pull up the spec, is they basically define like quad keys, I think, for tiles. So like this is more like sort of an arbitrary set of things where, you know, It's not even necessarily a regular mosaic grid, but a whole bunch of scenes, and you almost want to mosaic that on the fly. So this was an attempt to do that. And then Jeff Albrecht in his talk, like the Tyler and STAC integration, like they're actually making it so Jeff's doing one thing, which is adding to his STAC API the ability to just say /tiles, like, and get an OGC API tiles from any search endpoint. But to have it be smart and efficient about only rendering the bits that it needs, like not trying to read in every single cog, but understanding where those are. And then another idea is to have like a mosaic JSON sort of endpoint from a STAC API. So basically, I think you need a STAC API in there that has some smarts to know, like, hey, how do you order these things? How do you want to combine them together to then send out to the cogs efficiently? But yeah, let you kind of say like, oh, I want this whole catalog rendered that may be thousands of cogs, but they're not all going to be at the painted top level. So there just needs to be a bit of smarts on like, but yeah, those guys are the ones that are doing the most on it. So like I think they basically have it working, and the ability to kind of like query a large catalog and get a mosaic sort of rendered on the fly from it.
Okay. All right. I'll check those things out. Thanks.
Yeah, you should talk to them anyways, because I think Jeff was talking about a NAPE catalog. So yeah, we should align on,
right,
a solid NAPE STAC catalog that is as open as we can be.
Yeah, sounds good.
Yeah, I need to work on organizing the sprint tomorrow. I was hoping to do it last week, but got too busy. But hey, I want to try to set up some sessions that like are on some of this stuff. And yeah, I'll try to do one just on NAPE, because I know there's a few people that have looked at it and just get the way forward on what's the NAPE data set that we can make available in STAC and point everyone at.
Yeah, sounds good. I did talk to Joe Flasher a little bit about finding a open place to put that STAC catalog once it's created.
Nice. Cool. Any other questions? Well, then I will.
Just a quick one. I think, did you say that floating point data is not good for COG, or did I mishear that?
No, it's good for COG. It's just some of the renderers that people make on top of COGs might not work immediately as expected. And yeah, it's because we don't have enough like rendering hints to the tilers, because the tiler is pretty naive, and it just kind of reads the COG in. So some of those, depending on how your data is stretched and how it's defined, it may look lower, but I think what I've seen, they will attempt to render something, it just may be all dark or light or something. So
yeah, this is mainly for DEMs, right? Like you can have any value. So
yeah.
Thanks.
Awesome. Well, thanks so much for joining. My voice is certainly tired. But yeah, that was great. Thanks for all the questions. That made it much easier. I should have just tried to open. Next one of these, I may just open with questions and not try to start. But yeah, cool. So thanks for joining the session. I think we'll try to get most all the videos posted, hopefully in the next day or two. Yeah, join us for the sprint. Would love to see more of you trying to help convert data and help out and contribute to the ecosystem. But yeah, have a great day, everybody.